Hello, fellow Haskellers! Welcome to another episode of Giggles is You, now with the regular angle, because I got a new keyboard. Wait, the wire is not long enough for me to show you my new keyboard. I'm just making this, sorry. Anyway, new keyboard. Alright, putting everything back where they belong. Okay, so in today's episode, I would like to try something new. As you know, I really like to have short streaming sessions. I know that the convention, especially with gaming streams, is usually to have like streams that last several hours. But I think that for gaming streams, the context is a bit different than for programming streams. I think it is common to keep like gaming streams perhaps like in the background as entertainment and not as an object of focus and study, because I think games are perhaps a bit less intellectually challenging than programming, and so I think that for a programming stream, in order to get the benefit, it's probably more important for you to keep your full attention on what I'm trying to explain in order to get the benefits, and that's harder to do for a sustained period of time, and that's why I'm trying to have shorter streams than is the norm. Up to now, I've been aiming for 1 hour, and this time, like I said, I'm trying something new. I'm trying something even shorter. So please let me know if you find that better or worse than what I was doing before or what you're seeing elsewhere. And so in order to make it even shorter, like I'm always struggling to finish features in time within the hour, and then like I have to abort what I'm doing in the middle in order to keep to the schedule, and then it's like an unsatisfying ending. What I want to do this time is to, instead of implementing the feature live in front of your eyes, I want to show you the feature that I've already implemented. So hopefully I can do that in a much smaller number of minutes. So what is the feature that I have implemented? Well, if you remember in the last stream, I had implemented, let me go to the previous commit so I can show you what the code was looking like then. So, well, more than one episode ago, I had implemented this grammar in which I was recognizing a number of rules, name is push, name is stop, name is you, by recognizing a sequence of 3 words. So, for example, giggles is push, is the rule, name is push, giggles. And well, that's worked fine for exactly 3 words. And since I've implemented this as a grammar rather than some ad hoc code that, say, takes the first 3 elements of a list and checks that they are what I expect or something, it is very easy to extend this parser to parse more complicated rules, such as giggles on grass is push, which is the kind of rules that as I've explained a few episodes ago, it's the kind of rules that inspired me to create this series, because the original author of Baba Is You said he had to write some custom code to handle Baba Is You separately from Baba on Grass Is You, and I thought that, oh, in Haskell, it seems like with our parsers, I would be able to do that in one shot. So, yeah, that's why I used a parser. But then immediately after writing that parser, when I tried to hook it up in the game, I had to do some specialized handling for the case that has only 3 words. And that's the reason why the original author, Empoli, I think, had to write like specialized code paths for the 2. Like he had a code path for rules that have length 3 and rules that have like 5 or something. So I had to unfortunately do the same to hard code some special rules for when the length is 3. And I think it's in the same file actually in grammar. Here, when I'm trying to detect whether a rule or a number of rules, a set of rules apparently, appear in the level. I have an example level here, sets, where it says Giggles is you and text is push, and it looks like this. So we have on the left here, Giggles is you, and on the bottom, text is push. So those are the two rules that are currently active in the game. So thanks to Giggle is you, I can move this character Giggles up and down, left and right. And since text is push, I can push piece of text such as you here. And if I go back up here and I push is in between sheets and you, I form the new rule sheets is you, and so now this other character sheets here is also me, and so I can move around and move both characters. So that was the big conclusion of the last episode, that Giggles is you is now officially a Baba is you clone, because that's the main feature of Baba is you, is being able to form rules by pushing blocks. So great, we've got that done. But in order to achieve that, I had to cut some performance corners. So in the code that we were just looking at, not the code that defines the level, but the code that detects the rules, I was iterating through all of the rows and all of the columns of the level, and I was specifically looking for sequences of length 3. So where is it? It's not here. I think it's in the previous code, perhaps? Yeah, okay, I was already showing you the fix. Here's the code before the fix. So yeah, I was going through each row and extracting like a window of length 3, like if I'm going through a column, the first 3 cells, and then the like 1, 2, and 3, and then 2, 3, and 4, and then 3, 4, and 5, and so on. In order to then look at a sequence of 3 cells, figure out if they contain words, and then parse them using the grammar we just looked at. And the reason I had to do that was because I really needed the input to my grammar to be a list of words, because that's what I've defined it as. There's a ton of parameters, but it's this one, the third one, that describes the type of a single token that I'm parsing. So here, for example, the token function from the early library allows me to recognize the word called isWord, representing the word is. And since that was my input, I had to somehow massage what I had in my level into that format. And the problem was that in a single cell, it is possible to have more than one word, or even like more than one character in general, but like those entities could be words on top of each other. For example, if I run the game again, so for example, here I can move on top of the text, so now you and Giggles are on top of each other. And I could push a piece of text on top of another piece of text. So now I have you and is on top of each other. And so that means that it's possible to create much more, well, not more complex sentences. It's possible to have words that are on top of each other that are each part of a different sentence. So, for example, if I push sheets here on top of Giggles, then I can, like Giggles, like it's unreadable, but there's Giggles and sheet on top of each other, and so I am forming Giggles is you and sheets is you, but also like sheets is, which is not a rule. So I kind of need to consider all of those possible combinations of words in order to see which of those get parsed as rules. And the way in which I did that is, well, first I extracted sequences of length 3, and then for each of them, well, I just called get words, it's just to get all of the words that are stacked on top of each other in that particular cell position. But then I called sequence A, which iterates through all of the interleavings, right? So if I have a list of lists, then the inner lists indicate the fact that it's a non-deterministic computation. I can pick either the first word or the second word. And the outer list is that I want to run, according to sequence A, those three computations. In general, it could be any kind of side effect. In this case, it's a non-determinism effect, in that order and get the result. If there's three, I want to get three. In this case, I have three non-deterministic computations, each of which produces a word, and I want to get three words as a result. So that's why I get all of the combinations that I can get by picking any of the words from the first position, any of the words from the second position, any of the words from the third positions. And so in the case I just showed, I would have Giggles is you, Giggles is, Sheets is you, Sheets is. All of those combinations. And then I parse each of those. So yeah, I'm doing all of that extra effort in order to produce a list of words, a list of tokens, so that I can run my grammar. And that's not very performant, right? If there's n things stacked on top of each other in every cell, then that's n times n times n times n times n in order to evaluate all of those possible combinations. So that's is potentially a performance issue. Since I'm currently limiting it to 3, it's only n cubed, which is not that bad. It's not exponential, but still, I don't like it. And now that I want to support sentences that are longer than 3, it's bad. And so here is the solution which I came up with in order to improve the performance. So the code to call the parser is a bit simpler now. I'm not using a window, I'm not using sequence A, and the thing that allows me to not have to jump through those hoops is the fact that parse words is no longer using a word as its token, so it's not expecting a list of words as its input. Instead, it is taking a list of words as its token. That is, it is taking a list of words as its input, which is exactly the information that I have when I look at the world. When I go through a row, right, I have all of the information about all of the cells, or in a column, I have all of the information about all of the cells in this column, and since there can be many words in each cell, what I effectively have is a list of words. And so, okay, I'm just giving what I have to the grammar, so clearly it is the parser who is doing the heavy lifting now. So how can the parser deal with a list of words? It's very unusual. Like usually when we parse, well, it's already quite unusual to be parsing sequences of blocks from a game. Like usually when we parse, we have a piece of text, some string, and we want to first divide it into like lexemes, into tokens, like, oh, this is a string, this is a number, this is a keyword, this is a variable, and we want to assemble them together thanks to the parser, thanks to the grammar, into bigger things like, oh, this is an if expression, this is a function application, this is a function definition. But yeah, here I was able to skip the lexer in order to, I was able to skip the lexer because I didn't have a string to split up into words. I already had words because my blocks have one complete word on them. Now that I'm thinking about it, in Baba Is You, like in the late game, there's maybe I shouldn't be spoiling that, but you have words with individual letters on them, and you can form words that are much longer. You can form rules that are much longer than 3 or 5 cells, which makes me think that my my premise that the oh, the author didn't use a parser and we can do better in Haskell. It's probably wrong. Like, maybe it was right when he made the presentation, but like since then, like he must have used a parser in order to deal with such a complicated case in which your input is a bunch of letters rather than a bunch of words. But nevertheless, even if I have not successfully demonstrated that Haskell is a better choice than whatever Empoli used, I've still had fun, and in the end, isn't that what counts? And I hope you've enjoyed watching me re-implement Babayas in Haskell as well. Anyway, so back to the topic at hand. At this rate, I might not succeed at my goal at taking less than an hour for explaining what I've implemented. But in any case, yes, now it is the grammar that is doing the hard work because it is now receiving an unusual input. Like I said, it's already unusual that we're receiving words. Normally, we're receiving tokens that have been lexed by a previous phase. Now we are receiving pre-lexed words. Well, we are receiving pre-lexed words. We were receiving pre-lexed words before this change. Now we are receiving, like each token is a list of words, and that is highly unusual. And parsers deal very well with ambiguity in that, well, we have these OR rules, right? We're saying, oh, I can parse this either as this or as that. Figure it out. Like, conceptually, we're trying one, and if it doesn't work, we try the other. But like I explained in the previous episode, one big advantage of early is that it doesn't do that. It doesn't backtrack. It's smarter than this. It promises not to be exponential. I don't remember if it promises to be linear or quadratic or what, but I'm expecting something like linear, maybe like multiplied by like the length of the input multiplied by the number of rules, perhaps, or the number of pieces in the overall grammar. I expect something like that. But yeah, so it's very good at dealing with non-determinism, but nevertheless, its terminal function here that I was previously using here to detect a name, any name. I was saying, well, a word can be a number of things. Let's look at its definition. It can be a name, it can be the word is, the word you, the word stop, the word push. If I want to detect a name, any name, then I want to restrict my attention to those cases in which the constructor is name word. And the monad being used here, well, I'm not even using it automatically. The type being used here, terminal is taking a function from a word to a maybe, in this case, maybe name, whatever is being returned. And maybe indicates that for a terminal, it expects to either succeed at parsing exactly one thing or fail. Whereas what I would like is something very much like terminal, but in which I'm parsing a list of words, right? Because my token is a list of words, and so if I could ask for name, parse it as a name, then it would be very easy. I would filter down this list to only look at those that have the shape name word something. The code would look very much like this. But alas, I cannot, because the API for terminal asks for a maybe and not a list. And so I came up with an alternative. And in order to do that, I had to slightly change the way in which I define my entities. Is it in where's that? Types? Yes, here. So before, I supported a few entities. There's Giggles, which we've already seen, Sheets, which we've seen, Text, which is all of the pieces of text around, and another kind of entity that I haven't shown today, but we've seen in previous episodes, is the characters, because I only add 2 pieces of art for Giggles and Sheet that I borrowed from Word. Thank you, some space. But I didn't want to like draw like a wall and a box and all of those other fun entities that we can play with in the real Baba Is You game, which you should buy. It's a great game. So for the rest, I just drew like the letter A inside of a green circle, whatever. And I supported like all of the letters from A to Z, maybe even like all 128 ASCII characters. Not supporting all Unicode characters just because the font that comes with Gloss doesn't support all of them. In any case, I supported quite many characters, like 128 is still a bunch, and that I think that's unnecessarily too many for what I need anyway. And so I'm just simplifying it. There's only 6 in total. There's Giggles, Sheets, Text, A, B, and C. I don't need more than that. And so now that I've simplified it to be a finite number, 128 is finite as well, but a reasonable number, then I was able to change this implementation of name from looking at the word and restricting to see if it's the one case we care about. Since, like I said, it doesn't work because I want to return more than one. I'm using this now for name. I am iterating, so name has an enum instance and also a bounded instance, so that means that I can use minbound to talk about the first one, in this case Giggles name, and maxbound to talk about the last one, C name, and minbound ... maxbound to just list all of them. That's what I'm doing here. That's a command asking you to get a list of all of the names. And so for each of them, I am constructing the kind of piece of a rule that I would use up here, which I've constructed using this other helper word. So I am parsing the word, name word, that name. So this is very similar to token that we've seen before. In fact, why am I not doing that? Because token was previously taking a word, and that's what I was using here, right? In the previous limit, I was saying token is word, and that made sense because our tokens, like a token was a single token was a single word. So now if I change what a token is, then the function token would now take a list of words as input, and that's not what I want. So that's why I had to define my own function word for when I want to say, okay, I want to recognize this word and only this word. So same semantics, but in a new, in a world in which our tokens are lists of words, which is weird. So in that world, how do I recognize that a specific word is the next piece of the rule I'm trying to parse? It's simply, I'm looking through the list of words, and if I find it, then yeah, I can continue the rule by adding this word. So if I have already parsed Giggles is, and then the next cell has you and is on top of each other, then if I'm asking, okay, can I complete the rule Giggles is with the word you, then I check if you is one of the two possibilities, one of the two words that are stacked on top of each other. So that's why I'm implementing word this way. And so name is, I'm checking all of the names one after the other. Is it this word? Is it that word? Is it that word? Is it that word? And so the fact that's why I wanted to restrict it to a more reasonable number. Like there's only 6. So checking all of the names is not that much of an effort, I don't think. And yeah, if we match, then I don't want to return the word. In fact, word is not even returning anything. It's just returning init. I want to return the name, not the word. And that's it for how I've changed these rules here. And the only other thing which has changed is that before, that's it, that was the whole rule. I was expecting the entire input to be 3 words, and I parse those 3 words into a rule, and I'm done. But now, since I expect to parse the entire row or column as input, now I'm allowing to skip an arbitrary number of cells before the rule begins, and then after the rule has ended, so that I reach the end of the row. The end of the row. And so I'm calling this rule underscore, as usual. My naming scheme for conflicts. Oh, questions! Oh, question by Kmet. Yes, Popcorn. Parsing combinators for Baba is you puzzle game logic. Yes, that is what I'm doing. It doesn't have a timestamp. I don't know for how long I've been ignoring the chat. Thanks for interrupting. Lots of, despite the encouragement here, not lots of questions so far. Yeah, I'm ignoring the skip, which just accepts any token. And it works. My tests are passing, and like I could run the game again, but it's just the same behavior. Just not, I cannot end on as high of a demo as last time because there's nothing new to demo. It's the same behavior as before. It's just I assume it's more performant because I believe the claims of early that they are parsing everything without backtracking and therefore not in an exponential way. And so I think I did succeed at making even shorter stream than usual. Once again, let me know if you like that format better than usual or not, to know if I should continue doing it like this next time. And speaking of next time, see you next time. Ciao!